going to start coordinate continuous random variables and distributions. Before that, just we see that what we learned in your first and second unit. Okay, so in first unit, random variables, and before that basic probability people learn that one. So what is meant by sample space, what is meant by event, and what is meant by probability, and next addition theorem of probability, multiplication theorem, conditional event, dependent and independent events, and next Bayes theorem. And second part you learn random variables. So what is meant by that, which is a function mapping from sample space to real number. And types of random variables you learn discrete random variable and continuous random variables. In discrete random variables we learn distribution functions, and continuous random variable we learn density functions. Okay, and next second unit completely we learn discrete distributions. In that specifically we learned binomial distribution and Poisson distribution, and we saw the differences between that when we have to apply binomial and when we have to apply Poisson distribution. In Poisson distribution, if n is large and p is very small, which is approximately nearer to 0, in that case we use Poisson. And the disadvantage of binomial, for number of trials are more, then we can't apply binomial distributions. Okay, so those things we learned in second unit. Now we are going to learn continuous distributions. Okay, so continuous random variables and continuous distributions. In first unit we learned already continuous random variables and density functions. By taking those things, we are going to learn distributions here. In the distributions, first one is normal distribution, exponential distribution, and third one gamma distributions. Of course, remaining distributions also there, but as per silver we have here only three distributions. One is normal, exponential, and gamma distributions. Okay, so first normal distribution. So before going to that, just we see that what is meant by continuous distributions, all those things. Okay, so the distributions discussed so far are discrete distributions. It means in second unit we learn discrete distributions. Okay, there are what is meant by that, that is distributions in which the variate can take only integral values. Okay, it takes only finite values and we can say that fixed one. Okay, those things we learned in discrete random variables. It means that number of trials are, we can say that 100. Okay, and next we are saying that the probability is this one. Like that we can say that exact value. But in continuous we can't say that. Simply we can say that the height of the students. So height of the students means, can you say that exactly 4 feet or 5 feet? No, it is a continuous one. If you are taking your class from roll number 1 to roll number 63, so we have to check each and every individual. Roll number 1, so 4, and roll number 2, maybe 4.2 or 4.5, okay, or 4.6 or 5 feet or 5.2. Okay, 5.2, 5.3, like that. So it means for knowing the height of the civil students, we have to see each and every individual student. It means continuous process. From starting to till the end of that one, we need to check each and everything. So that is continuous distributions. But in discrete, no need to say like that. So what is the highest pass percentage in your class? Simply we can say that 75%, particular student. That is nothing but we can say that discrete. And here it is only, that's why we said, so in second unit we learned discrete distributions, that is nothing but distributions in that it takes only integral values. Okay, so examples of such distributions are, so just we saw already these examples, number of defective items.